Bismillahirrahmanirrahim. How are you, students? Today we will study physics, chapter number 4, lecture number 17. Chapter name is Work and Energy. Today first topic is power. What is power? Power is the rate at which energy is transferred, or the rate at which work is done is called power. Work per unit time is called power. Work is equal to energy. So it can be written as till E divided by T also. The unit of power is watt, work unit is joule, and time unit is second. Time is measured in second. Now, as we know that power is equal to work per unit time, and work is equal to F dot D. So power is equal to F dot D divided by T. So d divided by t is equal to velocity. Use it as a reference. Power will be equal to F dot V. Velocity and force. The dot product of velocity and force is called power. 1 horsepower is equal to 746 watt. Energy, the capacity of a body to do work, is called energy. Energy is the agent which causes some change in the state of an object. For example, water is in liquid state. Water is in liquid state. If we heat provide energy, it is converted into vapors. So energy changes the state of an object. Energy changes the state of an object. Similarly, if you take heat from the water, it is converted into ice. There are two types of energy. Potential energy and kinetic energy. Potential energy and kinetic energy. So, first we will define potential energy. Potential energy. First we will explain this one. The energy which is due to its position. Due to its position. Due to its position. Rest position. The energy which is due to some certain height. If this is earth surface and you take an object from the earth surface to a height h, potential energy will be equal to mgh. It is due to this position. If the body is lying on the earth surface, potential energy will be zero because height from the earth surface is zero. Now, as we know that work is the dot product of force and displacement. As we know that work is equal to F dot D. Here, in taking the body from this point, let's say to point B, from point A to point B, we cover a height h. We cover a height h. Now, F will be equal to weight of the body and it is equal to mg. D is equal to h. So, and this work is due to its position, due to its height. So, this work done will be equal to mg h means, right, this work we will replace by potential energy. This work is due to state of rest, so it will, we call this work as potential energy. And in place of F we write mg, and in place of D we will write H. So potential energy is equal to mgh. Kinetic energy, the energy which is due to its state of motion, due to its state of motion, due to its state of motion. Kinetic energy is due to state of motion. So let's say this is B position, this is A position. Initially the body is in state of rest. Force act on the body and displaces it, the body, to point B. At point B, velocity v is equal to vi. Distance covered is s, and acceleration is equal to f divided by m. So according to third equation, 2as is equal to v square minus vi square. 2 f divided by m s is equal to v square 0 square. So fs is equal to half mv square. This work done, this is work done, and this work is due to state of motion, so it is called kinetic energy. Use as a reference, kinetic energy is equal to work done, and work done is equal to F dot D is equal to F dot S. S and D represents distance, same quantity. So kinetic energy is equal to half mv square. In place of Fs, you write kinetic energy. And in place of half mv square, you will write the same. This is an equation to find the kinetic energy. So kinetic energy is due to state of motion, and potential energy is due to state of rest, due to some certain height. Implication of energy and energy law in practical devices and efficiency. Machine is a device which is used to increase the force and change the direction of force. So with the help of machine, you increase the amount of force and you change the direction. So machine is used basically basically to make the work easier, to make the work easier. Now input machine, input of mechanical machine, work done on a machine is called input. Input is equal to effort and distance through which effort is applied. Effort is the force applied or given to a machine. Input is equal to P cross D. Input is equal to P cross D. Output, work done by the machine, is called output. Output is equal to load and distance covered by load. Output is equal to W cross D. Efficiency is represented by eta, and it is the ratio of output to input. Percentage efficiency multiplied by 100%. So eta is equal to W cross D, P cross D multiplied by 100%. This represents percentage efficiency. Efficiency, the ratio of output of a machine to the input of a machine, is called efficiency. This symbol is called eta. This symbol is called eta. It represents efficiency. Output, input, eta, output, input, and it is in percentage. It has no unit because it is ratio. It is a ratio. Ideal machine. An ideal machine is a hypothetical machine whose output is equal to the input. This is equation. Efficiency of an ideal machine is 100% because there is no losses of energy in an ideal machine due to friction. Ideal machine are not possible, not exist, not exist. It's only a dream. It's a dream. The efficiency of a transformer. The efficiency of a transformer can be explained as the efficiency of a transformer can be explained as whose input is equal to output. Transformer is a device which convert low voltage into high voltage and high voltage into low voltage, increase the amount of voltage or decrease the amount of voltage. It's power at the input, power at the input is equal to power at the output. Power at the output. Pn is equal to P output. Power at the input is equal to power at the output. Absolute potential energy. Now we have to derive this relation. The energy, the potential energy possessed by a body at a certain height in a gravitational field with respect to reference point of zero potential is known as absolute potential energy. I will define it in a different way. To me, the potential energy per unit mass at that point, which is at a distance r from the center of the earth, is known as absolute potential energy. R. Absolute potential energy is the work done. Easiest definition. If someone asks from you, what is potential energy? What is absolute potential energy? The answer is very simple. Till it is a work, it is the work done. Taking a body from Earth's surface to a point where potential energy is zero, to a point where potential energy is zero. So if you take a body from Earth's surface to a point which is out of gravitational field, is called potential energy, absolute potential energy. This is the relation for absolute potential energy, and we have to derive. Okay. Remember this, these two equations, del R is equal to R2 minus R1 and R average is equal to R1 plus R2 divided by 2. And I will explain these two equations in the next. Now remember A plus B whole square, A plus B whole square is equal to first term ka square plus square of first term, square of second term, 2 into first term into second term. Absolute potential energy. This distance is equal to R1. This distance is equal to R2. So average will be equal to R1 plus R2 divided by 2. Average, this is the average distance. And del R is the difference between these two. This distance is del R. And when you subtract this distance from this distance, you will get it. Now, we will verify some equations. Absolute potential energy is further explained, but I will do a little derivation. I will do it here. Now, del R is equal to R2 minus R1 squaring. Both sides. Del R square is equal to R2 minus R1 whole square. Del R square is equal to R2 square minus R1 square plus R1 square minus 2 R1 R2. Now, as we know that R is equal to R2 plus R1 divided by 2. Now putting the value of R2, now take this equation and squaring. R square is equal to R1 plus R2 divided by 2 whole square. So R square, we will write R1 square plus R2 square plus 2R1 R2 divided by 4. So in place write R1 square, in place of R2 you will write R2, get the value of R2 from this equation. R2 is equal to del R minus R1, del R plus R1. So write del R plus R1 whole square plus 2R1 into del, uh, del R plus R1 whole square. You will write these values. So del R square, now write R1 square plus del R square plus R1 square plus 2 del R R1 plus 2 R1 del R plus 2R1 square. You will get this value. Ignore this term because this is very small value. This is very small value. So here is R1. Here is R1, 2R1. So write divide by 4. So you will take this R1, this R1, if any other exists. This term we will write, and this we will write this term also, and this also. So first I will erase, then I will explain the other terms. This derivation is not in book. I'm doing it for you people. So here some terms must be ignored. Now first write this term, and this term is equal to 2R1 square plus this term is 2 del R R1, 2R1 del R plus 2R1 and put the value of del R plus 2R1 R2 minus R1. This is the value of del R plus 2R, this is 2R1 square. So it will be added with this one. This will become 4. This will become 4. Divide by 4. So 4R1 square plus 2R1 del R plus 2R1 R2 plus 2R1 R2 minus 2R1 square divided by 4. Divided by 4. So Do the simplification. Here, put the value of del R. So when you put the value of del R, you will get, I will erase, I will write the short equation. So when you simplify that equation, you will get that R square is equal to R square is equal to 2R1 R2. R square is equal to 2R1 R2. Only R1 R2. So when you put R square, when you take the value R is equal to R2 plus R1 divided by 2, and del R is equal to R2 minus R1 divided by this one, and you just put the value of R2 from this equation into this equation and simplify, you will get R square is equal to R1 R2. You will get this equation equivalent to this one. Now, absolute potential energy of an object at a certain position is the work done by the gravitational field in displacing the object from that to infinity, where the force of gravity is zero. Taking Earth from out here, you take a body from this, or taking the body from this point to this point. Here the potential energy will be zero. The work done during this path is called absolute potential energy. Now, work from first point to second point. Taking a body from this point to this, or from this point to this point, from one point, from this line to this line. Let's say we have to find work. Here the force is gravitational, so write F dot del R. This distance is R1. This distance is R2. So del R is the difference between these two distances. So F dot del R, F dot is replaced by cos theta. F del R cos theta is cos 180 is equal to minus 1. So F del R, and here you write minus. Cos 180 is equal this the cos 180 is equal to minus 1. You will get this equation. Now gravitational force is equal to gmm divided by r square, and del r is equal to this. So work from 1 to 2, you put the value of force and del r, you got this equation. You got this equation. Now I will write this equation again for you people. Work from first point to second point is equal to minus g m divided by r square into r2 minus r1. So write minus g m divided by don't write divide, r2 minus r1 divided by r square. Right, minus g m r2 divided by r1 r2 minus r1 divided by r1 r2. Write this separately under this r2 and under r1 also. So as we have verified, r square is equal to r1 r2. Write this equation. So write minus g m 1 divided by r1 minus 1 divided by r2. Again I will write minus g capital M small m 1 divided by r1 minus 1 divided by r2. This is the equation. Now We will write the equation in generalized form. Similarly, work from 2 to 3 will be equal to minus G capital M 1 divided by R2 minus 1 divided by R3. Work from 3 to 4 is equal to minus G M 1 divided by R3 minus 1 divided by R4. Similarly, for nth term, for last term, work from n to n minus 1 to n. If n is 3, it will be from 2 to 3. So here in place of 3 we will write this. 1 is subtracted, you will get 2 and 3 n. It is written like this: minus gm m 1 divided by r n minus 1 minus 1 divided by r n. Now total work done will be equal to work from 1 to 2 plus work from 2 to 3 plus work from 3 to 4 plus dot 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 plus work from n minus 1 to n. So write in all these equations, you write minus gm m 1 divided by r1 minus 1 divided by r2 plus minus gm m 1 divided by r2 minus 1 divided by r3. You will write it. The last term will be minus gm m 1 divided by rn minus 1 divided by rn. Now gm is common, so take it common. So work done will be equal to minus gm m is common, so 1 divided by r1 minus 1 divided by r2 plus 1 divided by r minus plus 1 divided by r2 minus 1 divided by r3 plus 1 divided by r3 plus dot 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 plus 1 divided by rn minus 1 plus 1 divided by rn. This is cancelled with this is cancelled with this one. So this term is repeated before when it is written with plus. So this term will be repeated, so it will be also cancelled. So work is equal to minus g m 1 divided by r1 minus 1 divided by rn. This is the equation for absolute potential energy, in which work done is equal to gm m 1 divided by r1 minus 1 divided by rn. So r1 is the first term and rn is the last term. Now we will, if rn is at infinity, if rn is at infinity, then 1 divided by rn is equal to 0, will be equal to 0. So write del w, our work from first point to infinity, will be written minus gm m 1 divided by when Rn is at infinity, then R1 should be taken equal to the radius of Earth. So R minus 1 divided by infinity, we will write minus G m divided by R. It can be written as m divided by R. This is work done against the field. It is in the direction of the field. Work done against the gravitational field. So this is the most generalized form. Now, absolute potential energy, absolute potential energy is equal to W work done Gm m divided by R. It is equal to this one. We have derived with a negative sign, so write a negative sign. Absolute potential energy is represented by VR. It's a specific symbol. Minus Gm m divided by R. When it is divided by m, you will get this is the absolute energy per unit mass. So absolute potential energy per unit mass is Gm divided by R. It will be always constant. Otherwise, absolute potential energy will be equal to this one. So absolute potential energy is the amount of energy taking a body from Earth's surface to infinity. If this is Earth's surface, you take this body to this point. So if it is out of gravitational field, so the work done during this journey is called absolute potential energy. So absolute potential energy is the amount of work done in carrying a unit positive charge from infinity to a point at particular potential. Moving a body from Earth's surface to a point where the absolute potential energy is zero, out of gravitational field. Escape velocity is the next coming topic. So it's enough for today. We will revise a little bit. First, we explain power, rate of doing work. Then we explain energy, the ability of a body to do work. Kinetic energy, energy due to state of motion. Potential energy, the energy due to some certain height. Work done by a machine. Machine is a device which is used to increase the amount of force or change the direction of force. Input is the amount of work done on a machine. Output is the work done by the machine. Efficiency is the ratio of output to input. Ideal machine, in which input is equal to output. Power at the input is equal to power at the output. Will give you the efficiency of an ideal transformer. Absolute potential energy. Work done in moving a unit positive charge, and the amount of work done. Absolute potential energy Absolute potential energy is the amount of work done in moving an object from Earth's surface to a point where potential energy is zero. Thank you, students.